All right, factoring the trinomial completely. Here we are at 26 and 27, so let's go ahead and jump right in. And we'll rewrite 26 out to the side here so we have some room to work. All right, minus 12. All right, so we hopefully are now in the habit of asking ourselves those two questions. Number one, is there a GCF here? I don't see one, so we'll move on to question 2, which is how many terms are we working with? Well, 1, 2, 3, hence trinomial. And when we're factoring an expression of 3 terms, we're going to either use the scissors method or the AC method or trial and error method. I've been using the scissors method. That's what I'm most comfortable with. I think it's the fastest and most accurate way. And so scissors method says go ahead and list the factors of your coefficient of the squared term. So let's go ahead and let's set up a little chart like we've been doing. And you're also going to list the factors of your constant here, this last term. All right, so factors of 10, well, we have 1 and 10, 2 and 5. Factors of 12, well, we have 1 and 12, 2 and 6, 3 and 4. And you'll recall if you've watched the previous videos, we're always going to start with the factors that are closest together. 95% of the time, those will end up being the factors that you're going to work with. But if not, well, then you have plenty of other options and combinations to make. But let's go ahead and try these two factors. So we'll stack our 2 and our 5, and then we'll stack our 3 and 4, and if 3 and 4 don't work, we'll try 4 and 3. All right, let's go ahead and actually cross multiply. This is where the scissors name comes from, right? You can make a little pair of scissors out of the cross multiplication here. So 2 times 4, well, that gives us 8. 5 times 3, that gives us 15. Can we, in some combination, subtract 15 and 8 or 8 and 15 to get a positive 7? Yeah, well, sure we can. If we make this 15 a positive and this 8 a minus, we'll get to positive 7, right? 15 minus 8 gives us positive 7. And you'll recall whatever sign we put with the cross product simply bounces over. So we put a plus with our 15, so plus bounces over. We put a minus with our 8, so the minus bounces over. And then we simply wrap the factors in parentheses, and there you have it. So we have 2, don't forget to fill in your variable, so in this case z, plus 3, and here we have 5, don't forget your variable, z, minus 4, and if we wanted to write these out on one line, we'll have 2z plus 3, and then 5z minus 4, and there we have our factors of the trinomial 10z squared plus 7z minus 12. All right, let's look at 27 now. So 27, we have 10a squared plus 7ab minus 12b squared. And you might notice that these are almost identical, aren't they? We have a 10, a positive 7, negative 12, negative 12. So our factors are going to be the exact same, aren't they? The only thing that's really different is the leading variable that we use in 27 is different. Here we have an a, here we had a z. And in 27 we have an ending coefficient here, or a variable rather, don't we? It's a b, where there's no variable here. And so we could go through this whole process of listing our factors, and we'd wind up using the exact same numbers, except the only thing that's going to change is the leading variable is going to change because the variable changed from z to a. And instead of just having a constant as the last term in each binomial, well, now we're going to have the same constant, or number now, coefficient, we're going to just put a b on the end. So this is going to factor into 2z plus 3, oh, excuse me, not z, 2a, because that's the variable, the leading variable we're working with, plus 3, and now what's the ending variable? B. And 5z minus 4 is now going to become 5a minus 4b. All right, so let's go ahead and FOIL this out just so you can see that we do in fact get back to the original trinomial that we started with. So 2a times 5a, well, that gives us 10a squared. 2a times negative 4b gives us negative 8ab. 3b times 5a gives us plus 15ab. And lastly, 3b times negative 4b gives us negative 12b squared. We can combine our like terms, and so we get 10a squared plus 7ab minus 12b squared. And you'll notice that, yes, indeed, this trinomial does match the original trinomial we started with. So just be careful, be on the lookout. If you have a squared variable as the last term in your original trinomial, each of your factors have to have whatever variable is here in the end, right? So just like we kind of automatically put whatever the beginning variable is right into our set of parentheses, when you have that variable at the end, you also, whatever the coefficient ends up being, you have to then put the same letter twice to compensate, so that when you FOIL this out, you end up with a b squared and the double ab, or whatever the two letters are here in the middle. All right, so that was 26 and 27. Let's go ahead and take a look at 28 and 29.